Expected shortfall, S, is a risk measure, a concept used in the field of financial risk measurement to evaluate the market risk or credit risk of a portfolio. The expected shortfall at Q% level is the expected return on the portfolio in the worst Q, displaystyle Q, % of cases. S is an alternative to value at risk that is more sensitive to the shape of the tail of the loss distribution. Expected shortfall is also called conditional value at risk, CVaR, average value at risk, AVaR, and expected tail loss, ETL. S estimates the risk of an investment in a conservative way, focusing on the less profitable outcomes. For high values of Q, displaystyle Q, it ignores the most profitable but unlikely possibilities, while for small values of Q, displaystyle Q, it focuses on the worst losses. On the other hand, unlike the discounted maximum loss, even for lower values of Q, displaystyle Q, the expected shortfall does not consider only the single most catastrophic outcome. A value of Q, displaystyle Q, often used in practice, is 5%. Expected shortfall is a coherent, and moreover a spectral, measure of financial portfolio risk. It requires a quantile level, Q, displaystyle Q, and is defined to be the expected loss of portfolio value given that a loss is occurring at or below the Q, displaystyle Q, quantile. Formal definition: if X, L, P, F, displaystyle X in L caret P, mathcal F, closing curly bracket, an LP space, is the payoff of a portfolio at some future time and 0 less than alpha less than 1, displaystyle 0 less than alpha less than 1. Then we define the expected shortfall as E S alpha equals 1 alpha 0 alpha var gamma X D gamma displaystyle S underscore alpha equals frac 1 alpha int underscore 0 caret alpha m box var underscore gamma X D gamma, where var gamma displaystyle m box var underscore gamma is the value at risk. This can be equivalently written as E S alpha equals minus 1 alpha E X 1 opening curly bracket X X alpha closing curly bracket plus X alpha alpha minus P X X alpha displaystyle S underscore alpha equals frac 1 alpha left E X1 underscore X LEQ X underscore alpha plus X underscore alpha alpha P X LEQ X underscore alpha right closing curly bracket where X alpha equals IINF opening curly bracket X R P X X alpha closing curly bracket displaystyle X underscore alpha equals INF X in mathbar R P X LEQ X GEQ alpha is the lower alpha displaystyle alpha quantile and 1 A X equals opening curly bracket 1 if X A 0 else displaystyle 1 underscore A X equals begin cases 1 and text if X in A 0 and text else end cases is the indicator function. The dual representation is E S alpha equals IINF Q Q alpha E Q X displaystyle S underscore alpha equals INF underscore Q in mathcal Q underscore alpha E caret Q X closing curly bracket, where q alpha display style mathcal q underscore alpha is the set of probability measures which are absolutely continuous to the physical measure p display style p, such that d q d p alpha minus 1 display style frac dq dp leq alpha caret minus 1. Almost surely. Note that d q d p display style frac dq dp is the radon-Nikodym derivative of q display style q with respect to p display style p. If the underlying distribution for x display style x is a continuous distribution, then the expected shortfall is equivalent to the tail conditional expectation defined by T C E alpha x equals E minus x x minus V A R alpha x display style TCE underscore alpha x equals E x mid x leq var underscore alpha x closing curly bracket. Informally and non-rigorously, this equation amounts to saying, in case of losses so severe that they occur only alpha% of the time, what is our average loss? Expected shortfall can also be written as a distortion risk measure given by the distortion function g x equals opening curly bracket x1 minus alpha if 0 x less than 1 minus alpha 1 if 1 minus alpha x 1 display style g x equals begin cases frac x1 alpha and text if 0 leq x less than 1 alpha 1 and text if 1 alpha leq x leq 1 end cases. Examples. Example 1. If we believe our average loss on the worst 5% of the possible outcomes for our portfolio is EUR 1,000, then we could say our expected shortfall is €1,000 for the 5% tail. Example 2. Consider a portfolio that will have the following possible values at the end of the period. Now assume that we paid 100 at the beginning of the period for this portfolio. Then the profit in each case is ending value minus 100. Or, from this table let us calculate the expected shortfall. E S Q display style S underscore Q for a few values of Q display style Q. To see how these values were calculated, consider the calculation of E S 0.05 display style S underscore 0.05. The expectation in the worst 5% of cases. These cases belong to are a subset of row 1 in the profit table, which have a profit of minus 100. Total loss of the 100 invested. The expected profit for these cases is minus 100. Now consider the calculation of E S 0.20 display style S underscore 0.20. The expectation in the worst 20 out of 100 cases. These cases are as follows: 10 cases from row 1 and 10 cases from row 2. Note that 10 plus 10 equals the desired 20 cases. For row 1 there is a profit of minus 100, while for row 2 a profit of minus 20. Using the expected value formula we get 10, 100, minus 100, plus 10, 100, minus 20, 20, 100, equals minus 60. Display style frac 10, 100, minus 100, plus frac 10, 100, minus 20. frac 20, 100 equals minus 60. Closing curly bracket. Similarly, for any value of q, display style q, we select as many rows starting from the top as are necessary to give a cumulative probability of q, display style q, and then calculate an expectation over those cases. In general, the last row selected may not be fully used. For example, in calculating s 0.20, display style s underscore 0.20, we used only 10 of the 30 cases per 100 provided by row 2. As a final example, calculate s 1, display style s underscore 1. This is the expectation over all cases, or 0.1 minus 100 plus 0.3 minus 20 plus 0.4 0 plus 0.2 50 equals minus 6. Display style 0.1 minus 100 plus 0.3 minus 20 plus 0.4 CDOT 0 plus 0.2 CDOT 50 equals minus 6. Backslash. Closing curly bracket. The value at risk, VaR, is given below for comparison. Properties. The expected shortfall, S, Q, display style S underscore Q, increases as Q, display style Q, decreases. The 100% quantile expected shortfall, S, 1.0, display style S underscore 1.0, equals the expected value of the portfolio. For a given portfolio, the expected shortfall, S, Q, display style S underscore Q, is greater than or equal to the value at risk, VaR, Q, display style operator name VaR underscore Q, at the same Q, display style Q, level. Dynamic expected shortfall. The conditional version of the expected shortfall at the time t is defined by S alpha t x equals asterisk S sup q alpha t q minus x f t display style S underscore alpha caret t x equals operator name asterisk S sup underscore q in mathcal q underscore alpha caret t e caret q x mid mathcal f underscore t closing curly bracket where q alpha t equals opening curly bracket q equals p pipe f t d q d p alpha t minus 1 a s closing curly bracket display style mathcal q underscore alpha caret t equals q equals p that underscore mathcal f underscore t frac dq dp leq alpha underscore t caret minus 1 mathroom a s closing curly bracket backslash closing curly bracket closing curly bracket. This is not a time-consistent risk measure. The time-consistent version is given by rho alpha t x equals asterisk s sup q tilde alpha t q minus x f t display style rho underscore alpha caret t x equals operator name asterisk S sup underscore q in tilde mathcal q underscore alpha caret t e caret q x mid mathcal f underscore t closing curly bracket such that q tilde alpha t equals opening curly bracket q p E, D, Q, D, P, F, tau, plus 1, alpha, T, minus 1, E, D, Q, D, P, F, tau, tau, T, A, S, closing curly bracket, display style, tilde, mathcal, Q, underscore, alpha, caret, T, equals, left Q, LLP, mathvar, E, left, frac, DQ, DP, mid, mathcal, F, underscore, tau plus 1, right, LEQ, alpha underscore, T, caret, minus 1, mathvar, E, left, frac, DQ, DP, mid, mathcal, F, underscore, tau, right, backslash, foral, tau, GEQT, mathroom, A, S, right, closing curly bracket. See also, coherent risk measure, EMP for stochastic programming, solution technology for optimization problems involving S and VaR, entropic value at risk, methods of statistical estimation of VaR and S can be found in Embretts al. and Novak. When forecasting VaR and S, or optimizing portfolios to minimize tail risk, it is important to account for asymmetric dependence and non-normalities in the distribution of stock returns such as autoregression, asymmetric volatility, skewness, and kurtosis. Rockefeller, Yosef, Optimization of Conditional Value at Risk. 2000. C. Iserby and D. Tasha, On the Coherence of Expected Shortfall. 2002. Rockefeller, Yosef, Conditional Value at Risk for General Loss Distributions. 2002. Iserby, Spectral Measures of Risk. 2005. Phi Alpha Optimal Portfolios and Extreme Risk Management. Best of Wilmot. 2003. CTAC Antoine.